Hey everybody, it's time for math. I'm Mr. Troy.
And this is Miss Judd.
All right, we're looking into writing equations of lines. We're going to take some of the linear functions that we've just graphed, and we're going to flip that on its head. We're going to learn how to take a graph and write an equation for it. Our overall goal for this unit is to write equations to explain how the x and y values are related to each other in linear functions. Sounds like a blast? Here goes. So we're going to start today with slope-intercept form. A reminder of what slope-intercept form is. It's a type of linear equation where you know the slope, which is the coefficient of the variable or the number in front of the variable, and you know the y-intercept. Now the y-intercept is going to be a point 0, comma b. So in the case of this one up here, 0, comma 3 would be the y-intercept.
So here's an example. Say we're given this graph and asked to write its equation. Well, we'd like to write it in this most simple form, which is y equals mx plus b, slope-intercept form. And so to do that, what we need is a slope and we need a y-intercept. So I like to start with the y-intercept. Go over to the graph. Remember, the y-intercept is where the graph crosses the y-axis. So that is at here at this point 0, negative 4. And then the slope is how we count from that y-intercept up to the next perfect point. So if I look, my next perfect point is right here at 1, negative 2. And so my slope then would be up 2 and right 1. So we always do rise over run, so it would be slope of 2 over 1. Which means that our equation would ultimately be y equals 2x minus 4. So our slope is 2 and our y-intercept is negative 4. Now we can always check our answers by plugging in any solution to see if it makes the equation true. So let me pick a solution that isn't one I've already used. So a perfect point, here's a perfect point. Let's try the point 3, 2. So if I go to my equation, y equals 2x minus 4, and I plug 3 in for x and 2 in for y, so that would be 2 equals 2 times 3 minus 4, and I'm going to see if it's a true statement. So let's see. Well, the left stays as 2, the right becomes 6 minus 4, and we get 2 equals 2. So that checks, which means our equation must be true for this graph.
All right, next equation. So this time I see that I have a line that is sloping downwards. I see two nice points here, the x-intercept and the y-intercept. So again, my slope is my change in y over my change in x. So from my leftmost point here, my change in y is down 1, 2, 3, 4, 5, 6, 7, 8. Down 8 means negative 8. And my change in x is positive 2, because I'm going 2 to the right. So a slope of negative 8 over 2 reduces to a slope of negative 4. My y-intercept is negative 8, so that gives me an equation of y equals negative 4x minus 8. If I plug in the point negative 2, 0, I can check that this is correct.
So just like before, we're going to try to write our equations in slope-intercept form, y equals mx plus b. which means that we need to find our m, which is the slope, and our b, which is the y-intercept. And I like to start with my y-intercept, so I'm going to look at my graph and find out where it crosses the y-axis. That's here at the point 0, 2. So that means the b is 2. So behind the x, I'm going to put a plus 2. And then I need to find my slope. So to find my slope, I need to move to another nice point. So let's see, as I follow this down, it looks like my other nice point is down here at 3, -3. And so I'm going to count my rise. That's down 1, 2, 3, 4, 5. Right, 1, 2, 3. And because it's right, it's a positive 3. So my slope is -5 over positive 3. And so I'm going to put that in the m spot. So it looks as if my equation is y equals -5/3 x plus 2. But I'd like to check it. And to check, I need to find another perfect point on the graph. But unfortunately, when I look at this graph, there aren't any other perfect points. So what I'm going to do is I'm going to check by plugging in a value for x and seeing what I get out for y. So let's choose a value for x. I'm going to choose -2. And so if I plug in -2 for x, I'm going to see what I get out for y. And so if I do that, that turns out to be 16/3, which is approximately 5.3 repeating. So if I go to -2 and then I look up, does that point look like it's about 5 1/3 or 5.3? It does. So I would say that my equation is at least really close. I can't check perfect unless I have a perfect point. So at this point in the lesson, I'd like you to take a look at the few practice problems that are at the bottom of your note sheet.